This is Algebra 2, Lesson 13-8, Properties of Logarithms. So there are three new logarithms for today. Here's the first one. If you have the same log base, this rule works. So if I multiply the insides, x is being multiplied by y, that's the same thing as taking x and y into separate logarithms and I add the outsides. So there's the rule in algebra, but in words, I would say that if I multiply the inside, then I would add the outside. And that's not necessarily a super formal rule, but it's the one that I want you to memorize. And it's also worthwhile asking why. Why does this rule work? Because technically, when you write a logarithm, this answer is a power. Remember that a logarithm is a what power function. And the answer to what power does b need to be raised to, this thing is in itself a power. And that means I can treat this entire thing as a power of x. So I can say that this x and this y are powers. And what happens when I multiply powers that have the same base? Again, I have the same base. When I multiply those powers, or when I multiply those bases rather, these powers get added. And that, we know that from the past. So we say this is the same thing as x plus y. And therefore we have an x plus y. We are adding a power to a power when we are really trying to multiply those powers. All right, what happens if I do the reverse? And you probably have some pretty good intuition. Well, the reverse of multiplication, Mr. Sindel, is division. Therefore, this one is division. When you divide the inside, then you're probably going to do the opposite as well. If this says add, then this is going to be subtract, and you would be correct. Subtract. And indeed, that is the rule. When I have my division, that turns into subtraction. So divide the inside is the same as subtracting the outside. So if I have my rationale is over here. When I had the same base and the same base, again, if I had x in the numerator, y in the denominator, our shortcut up here said that this is x minus y, which is exactly what I have right here. This is a power of x minus a power of y, just what I have over here. And then finally, this one is a little bit tricky compared to the other two, but it is really, really useful. It can create some really difficult problems in our future. So again, we always assume, just like all the last problems, that we have the same base. That should always be the same for all of these properties. But this n, this power of n, is trapped on the inside, and you are allowed to move this out to the front of this. And I'm going to leave that in pen. So this power of n can come out to the front, and this becomes n of everything else. This is the exact same copy paste of log base b of x, log base b of x. So the n now lives in front. And you can do this vice versa, right? You can say this n might live out in front of the logarithm and be multiplied. And there is indeed a multiplication symbol here. But you are also allowed to move that n inside to the power of x. And a lot of students ask, how is that possible? How are you allowed to randomly change a power to multiplication? And again, it comes from our properties of exponents. If I had a power to a power, again, this entire thing is a power to a power to a power, then I multiply these powers. This is going to say x times n. So a power to a power really meant multiplication, and there it is. This is a power multiplied by another power. And there's where those come from. So in general, what I just say here is that the power, or the exponent, I'm going to use the word power, the power goes in front. You are allowed to switch these positions. So other reminders that are going to really help for this homework assignment, and especially for the quiz, is whenever you take the square root or the cube root or anything like that, we have rational exponents, meaning that this hidden index, by the way, is 2. We just don't write it. We call that the square root with no index. This is the same thing as x to the power of, you guessed it, 1/2. And then if I have a cube root of x, that's the same thing as x to the power of 1/3. Another cool thing is how you can break apart radicals. If I have the square root of xy, it's the same thing as saying the square root of x times the square root of y individually. These two radicals can be split apart, and it goes vice versa. If I have these two radicals, I can combine them into one radical, and that's probably the property that you're going to be using. You're going to be going this direction today, where you have a square root and another square root, and you're going to combine them all into one square root. I think you're actually going to go backwards and forwards. You're going to go this direction, and you're going to go this direction. We'll see here in a few examples. Let's see. Number one. So whenever I see the word expand, that means it's going to get larger. There's going to be multiple logarithms. Right now I only have one logarithm. I should have probably at least two logarithms since I have two variables, as opposed to the opposite of this, which is condensed, where I have a bunch of stuff, and I want this all as one logarithmic expression. So for our first example, I know that whenever I have a power of 5, I can kind of distribute that right from the beginning, and then I can start to deal with what's going on here. So again, I could just move this 5 out in front. That also would work. You can kind of choose whichever one you want. I prefer to kind of distribute to the inside and move from there, but if you want to go ahead and move that 5 out in front, that is still okay. Okay, so this is now going to say log base 3 of, and then in here I have a power of 3 to a power of 5. Again, a power to a power means multiply, so 3 times 5 is 15. So it's going to be a to the power of 15 divided by, and then this b is technically to a power of 1, and 1 times 5 is 5. So this is just b to the power of 5 in the denominator. And there's my first step. And my next step is to say, okay, well, if I divide the insides here, that's the same thing as subtracting the outside. So I can have two different logarithmic expressions, both of them base 3. I'm going to say log base 3 of a to the power of 15. And I'm going to say subtract log base 3 of b to the power of 5. And I don't need parentheses. I'm going to put the parentheses just to make sure that you can follow. And again, I can go even further. I can go ahead and say I can bring that 15 down in front. So now this is going to be 15 log base 3 of a minus, and then this 5 can come down in front as well. This can say 5 log base 3 of b. And you can see that what we started with was something that was a little bit more condensed, and this is a lot longer because it has 1, 2, 3, 4, 5 parts, and this one kind of had 1, 2 parts, I guess. Maybe even consider that all one part. So it has gotten a lot longer. It has been expanded. Let's try it again. So this one is another type of example where, again, I have multiplication happening here, multiplication happening here. Again, multiplying means I'm going to be adding. Multiply the inside means add the outsides. So I'm going to have a bunch of log base 7s. I'm going to write log base 7. And the first one is going to be w squared. And then I'm going to, that one was multiplying the inside, so I'm now going to add the outsides. I'm going to say log base 7, still it's always base 7 of, and then I can kind of separate these into two different pieces. I'm going to say for the first one is the square root of x, and then this is going to be added with the next one, which is going to be still log base 7 of now the square root of y. I'm allowed to break those up. And this is helpful to know that the square root of x, I'm just going to go ahead and write a line up here. That's the same thing as x to the power of 1/2. And the square root of y is the same thing as y to the power of 1/2. And do I have enough room? I have enough room where I can just show that as an entirely separate step. So let me go ahead and do that instead, because that'll show up nicer for our notes. So I'm going to go ahead and say this is still log base 7 of w squared. That hasn't changed. But over here, this is going to be log base 7 of x to the power of 1/2. And this is going to be plus log base 7 of y, also to the power of 1/2. Okay, so now each of these has a power that can come down in front, a power that can come down in front, a power that can come down in front. Let's go ahead and rewrite all of this. This is going to be 2 log base 7 of w plus 1/2 of log base 7 of x plus 1/2 of log base 7 of y. Cool. And then I know that sometimes in the answer key, when they have a half here, sometimes that just means they take this entire thing and we divide it by 2. That's also okay. I just like leaving the 1/2 out in front because it makes more sense for me to be able to bring that up to the inside power as 1/2 like this. Just be ready that it could theoretically be divided by 2 as well. All right, let's try going the other direction, condensing things. So now it's just the reverse of what I did, right? So now I have a power of 4 that's being multiplied. This power of 4 is going to come up to the power, of course, and I can say this is now log base 8 of x to the power of 4. And then what do we have over here? Yeah, so notice that they put the 3 over here, but this is the same thing as writing 1/3 out in front. This 1/3 is going to live up here, so this is now going to say log base 8 of y to the power of 1/3. And then this is going to be plus, again, log base 8 still of z to the power of 1/3. All right, and now I can say, okay, when I add the outsides, it's the same thing as multiplying the insides. So I can kind of squish all of these things together on the insides and just have one logarithm. This is going to be log still base 8. And I'm never going to try to trick you guys. Like, if this is base 8, these all should be base 8 as well. But just be paying attention. Maybe if you're taking some sort of state exam, maybe they'll try to switch these up on you. I still strongly doubt that, because they wouldn't be assessing any valuable skill. It's a random, trivial like red herring question that no one would ask. Okay, so it's going to be log base 8 of x to the power 4 times, again, when I add the outsides, I'm multiplying the insides. And then this is y to the power of 1, 3 is the same thing as the cube root of y. Times, again, now I have another cube root of z. This is going to be cube root of z. And I'm still not done, because these two radicals have the same index, which means they can be combined into one radical. And I can say that this entire thing is log base 8 of x to the power 4 cube root of yz. And now this is as simple as I can get, and I'll end my parentheses. And our final example number 4. Again, I have divided by 2, which is the same thing as putting a 1/2 out in the front. So this 1/2 is going to come and live up here as a power. So this is really going to be a to the power of 1/2. So I'm going to come here and say this is log base 2 of a to the power of 1/2 minus, and then again, this 6 is going to live up here as a power. And this is going to be log base 2 of b to the power of 6. Make sure that your b's and 6 looks different. The b should be nice and straight right here, and then the 6 should be a lot curvier over here. All right, so if I am subtracting the outsides, I am dividing the inside. So the inside is going to be log base 2 of the inside, which is a to the power of 1/2. By the way, to the power of 1/2 is just the square root of a. So I'm going to say the square root of a in the numerator, and then I'm going to divide by the denominator. The denominator is this b to the power of 6, which is going to come live down here. I'm going to write b to the power of 6, and I'm done. Cool. Well, that concludes the notes for topic 13-8 for Algebra 2's properties of logarithms. Thanks for watching.